What are the secrets of solid figures that can help solve the mysteries of the universe? Solid figures are figures in space that have a size in length, width, and height. We commonly call figures with volume a solid figure. The world is made up of various solid figures, including prisms, pyramids, cones, and spheres. Some solid figures are made by rotating plane figures. Unlike plane figures, you cannot see every part of a solid figure at once. Therefore, to fully understand solid figures, you must observe them by touching and rotating them around. Solid figures can be classified into two categories, polyhedron and non-polyhedron. Polyhedron comes from a Greek word that means many faces. A polyhedron is a solid figure that consists of flat faces. If a solid figure has a side that is not flat, then it cannot be called a polyhedron. A solid figure is made when a two-dimensional figure is moved in a three-dimensional space. For example, the traces of a rectangle lifted vertically constructs a rectangular parallelepiped. A massive explosion took place about 13.7 billion years ago. That explosion is called the Big Bang, which leads to the birth of the universe. The Big Bang occurred within an unbelievably short time, but it is the most important moment in the birth of the universe. The energy from the explosion formed almost half of the space in today's universe and then rapidly spread out. However, the first universal space only had radiant energy. In other words, there was only light, and nothing that could be called matter. Much later, some of the radiant energy turned into matter. As the hot universe slowly cooled down, the protons and neutrons created a nuclear fusion reaction and made atomic nuclei. The atomic nuclei combined with electrons and formed atoms like hydrogen and helium. As the light that filled the universe slowly weakened, the era of matter began. Over 100 billion galaxies were made as hydrogen and helium combined, and within each galaxy over 100 billion stars were born. The Sun is one of them. Then, planets formed around the Sun. One of the planets is Earth, the planet we live in. It took about 13.7 billion years since the creation of Earth and the emergence of mankind to achieve today's modern civilization. Then how big is the universe? To calculate, we first need to know that light is the fastest thing in the universe. Although some of the light formed during the birth of the universe turned into matter, those that didn't are still traveling at the speed of light. If space expanded at the speed of light since its birth, the radius of the universe can be as big as 13.7 billion light years. That is how unimaginably large the universe is. We still haven't seen the edge of the universe. If we can observe every galaxy and reach the end of the universe, we would finally be able to solve the mystery. Then what exists beyond the universe? The universe came into existence and expanded without time or space. That said, there is probably no time or space beyond the universe. What we understand today is that about 73% of the universe is composed of dark energy and only 27% are matter. However, we have only accurately identified 4% of the discovered matter, and the rest, 23%, remains mysterious dark matter. Since ancient times, people have always been interested in the universe. They thought the basic elements of the universe were fire, air, water, and earth. Greek philosopher Plato claimed that fire has a shape of a regular tetrahedron, earth a cube, water a regular icosahedron, and air a regular octahedron. Although the discovery and proof of 5 types of convex regular polyhedron was Pythagoras' school's achievement, regular polyhedrons are called Platonic solids, as they were first mentioned in Plato's Timaeus. A solid figure that has the same number of faces meeting at each vertex and every face is a congruent regular polygon is called a regular polyhedron. A prism is a polyhedron that has straight edges and same cross-sections that are parallel to the base. The bases of a prism are parallel, and the faces are a rectangle. There are special prisms that only consist of rectangles, known as a rectangular parallelepiped. Here, you can conclude that the shape of its base determines the name of a prism. For example, if the base is a pentagon, it's a pentagonal prism, and if it's a hexagon, it's called a hexagonal prism. Although a paper is very thin, because it has a thickness, it is still a solid figure. But because papers are so thin and flat, most people think paper as a plain figure. For example, we don't call shapes like triangles, squares, and circles cut out of a paper a triangular prism, rectangular prism, or cylinder. It is helpful to study solid figures with pictures or drawings that directly constructs a solid figure. There are various ways to draw solid figures on a plane. Perspective drawing has an advantage in that we can draw figures as if we are directly looking at the solid figures. Here, things further away are drawn smaller and things closer bigger to convey depth when drawn on a flat surface. Using sketches and nets of solids also help when trying to understand solid figures. A sketch is drawing a figure from an angle, and a net is drawing how a solid figure would look like when it is spread out on a flat surface. A sketch is convenient to use when examining a solid figure's overall shape and its curved or straight edges. A net is used when examining what plane figures make up a solid figure. Parallel projection, where you project a ray of light to an object and observe its shadow to determine the shape of an object, is also helpful in understanding solid figures. Practicing what a solid figure may look like based on its shadows could help in the development of the ability to see the invisible. Observing the cross-section can help us understand not just the outside but also the inside of a figure. The universe consists of solid figures. The objective of studying solid figures is to understand the universe. If we can find out the hidden secrets of solid figures, we can understand the mysteries of the universe and at the same time understand the secrets of the human body. This is possible because the structure of the human body and the universe are both fractal structures. Let's find out the logical evidence about the birth of the universe and its structure. We call a solid figure made up of multiple polygons a polyhedron. No two polygon consisting a polyhedron exists on the same plane. A face refers a polygon consisting a polyhedron, an edge is the sides of the polygon, and the vertex of the polyhedron is the vertex of the polygon. A polyhedron is categorized as a tetrahedron, pentahedron, hexahedron, and so on, and more depending on the number of faces it has. For example, every face of a regular tetrahedron and cube are congruent regular polygons. A regular polyhedron is a convex polyhedron that has the same number of faces meeting at each vertex with all faces that are congruent regular polygons. There are only 5 types of regular polyhedrons: a regular tetrahedron, cube, regular octahedron, regular dodecahedron, and regular icosahedron. The ancient Egyptians already knew about regular tetrahedrons, cubes, and regular octahedrons, but it was the Greeks that studied them mathematically. The regular tetrahedron, cube, and regular octahedron were discovered in theory by Pythagoras and his disciples, while Theodotus discovered, in theory, the regular dodecahedron and regular icosahedron. The 5 regular polyhedrons are also called Platonic solids. As we already mentioned, Plato intuitively claimed the 4 elements, fire, air, water, and earth, to be related to regular polyhedrons. According to him, because the universe and our world can only be made up of perfect solids, and the elements must also be regular polyhedrons. Plato thought the form of the fire, the lightest and sharpest element, to be a regular tetrahedron, earth, the most stable element, a cube, and water, the most fluid element, to be a regular icosahedron. When you lightly hold the 2 opposite vertices of a regular octahedron with your thumb and index finger and gently blow on it, it rotates easily, which shows the instability of air. Plato also believed the regular dodecahedron is the representation of the universe because it contained the 4 elements. Plato thought the regular dodecahedron to express the universe and said, God used this for the creation of the whole universe. Then why are there only 5 types of regular polyhedrons? Let's make a regular polyhedron using an equilateral triangle. Keep in mind that each of their interior angles is 60 degrees. We can make solid figures that have 3, 4, or 5 equilateral triangles that converge at one vertex. If we were to have 6 equilateral triangles to converge into one vertex, the sum of the interior angle would be 360 degrees, making it a plane, so we would not be able to make a solid figure. We also can't make a solid figure with just 1 or 2 equilateral triangles. Thus, there are only 3 regular polyhedrons with an equilateral triangle as the face: a regular tetrahedron, regular octahedron, and regular icosahedron. This time let's use a square, which has an interior angle of 90 degrees, to find what regular polyhedrons we can make. In this case, we can make a solid figure when 3 squares converge into a vertex. If four squares were to converge into a vertex, the sum of the interior angles would be 360 degrees, making it a plane. Thus, there is only one regular polyhedron, a cube, that we can make with a square. A regular octagon's interior angle is 108 degrees. Therefore, a solid figure can be made only when three regular octagons gather around a vertex. In this case, if more than three regular octagons gather, the sum of the interior angle exceeds 360 degrees, so you cannot make a convex solid figure. Therefore, you can only build a regular dodecahedron with only regular octagons. Lastly, what regular polyhedron can we make with a regular hexagon? One interior angle of a regular hexagon is 120 degrees. Therefore, if three regular hexagons converge into a vertex, the sum of the interior angles become 360 degrees, making it a plane. So, we cannot make a solid figure. Likewise, we cannot build a regular polyhedron with a regular heptagon, octagon, nonagon, or any other shapes with more than 6 sides. A solid of revolution is a solid figure created by rotating a plane figure around a straight line. By rotating a rectangle with its side as an axis, or a right triangle with the base as an axis, or a semicircle with the diameter as an axis, you get a cylinder, cone, and sphere respectively. When you rotate a rectangular-shaped paper around a stick, you get a cylinder, where the two bases are a circle, and the side is a curved surface. If you rotate a right triangle-shaped paper, you will get a cone with a circular base and a curved side. The solid figure you get by rotating plane figures, like a rectangle or a right triangle, on a straight line is called a solid of revolution. Here the straight line used as an axis is called an axis of revolution. Uneven distribution of mass around from an equal distance of an axis of rotation causes vibrations to occur for each rotation. Therefore, it's important to be able to reduce the vibration to improve the performance and lengthen the lifespan of machines. This technique of controlling the unevenness of the rotation is known as balancing. Balancing incorporates the theory of volume of solid figures. A car engine often breaks down due to vibrations caused by an imbalance in the rotation. So, balancing rotation is necessary to lengthen the lifespan of the machine. If you rotate a circle with the diameter as the axis of revolution, you get a sphere. Just like the distance from the center to the edge of a circle is equal, the distance from the center to the surface of a sphere is also equal. The sphere has the highest surface area to volume ratio. In other words, when comparing solid figures with the same volume, the sphere has the smallest surface area. The reason we can find so many spheres or shapes that closely resemble a sphere in nature is due to its law of survival, to get the most output from the least input. Bubbles, raindrops, stars and planets with gravity are all spheres. When gravity exerts equal force in all directions, you'll get a sphere shape, just like how hot gas expands. However, other types of forces simultaneously exert to distort the sphere. For example, a raindrop is a perfect sphere in the air, but as it falls to the ground, other forces flattens it out. A cylinder has a similar shape to a prism, but it is different because its sides are curved and the base is a circle. We can calculate a cylinder's volume by multiplying the area of the base, a circle, by its height. Contrary to popular belief, pizza is a cylinder, not a circle. That's because the pizza bread has a height. Great Swiss mathematician Euler discovered that the number of faces plus number of vertices minus number of edges of a polyhedron is always 2. If you turn that into a formula, it becomes F plus V minus E equals 2. Here, F, V, E represents the number of faces, vertices, and edges respectively. For example, a cube and a cuboid both have 6 faces, 8 vertices, and 12 edges. Using Euler's formula, it will be 6 plus 8 minus 12 equals 2. The Platonic solids mentioned earlier are ideal shapes for a fair dice. A fair dice refers to a dice that has equal probability to land on each face when thrown. We are typically familiar with a cube-faced die. But a fair dice does not always have to be a cube. A die can have as many faces as we want it to have. What can we make if we understand solid figures? Math is the study of discovering the secrets of nature. By learning the secrets of nature, we can create things that can make people happy. Then what makes people happy? People today would be happy if we can soothe their loneliness and understand their delicate emotions. Also, developing new medicine or technology that can prevent or predict diseases to help achieve longevity in real life is also related to human happiness. People will be happier if we make medical diagnostic equipment technology, like the MRI and CT, that allows us to treat a disease in time through accurate diagnosis. It is hard to conclude that we understand a solid figure just by looking from outside because we still do not know the inside of the solid figure. To examine the inside of solid figures, we first have to cut it and draw its cross-section. A CT, computed tomography, scans the cross-sections of a solid figure. A CT scan provides a lot more information than an ordinary X-ray picture. In fact, during a CT scan in the hospital, a series of clips and hundreds of images of the inside of the patient are taken and saved on the computer. It produces tomographic cross-sectional images, a slice of the whole figure, which means you cannot accurately assess the overall condition inside of the body, a solid figure, with just one image. For example, let's imagine someone with cancer undergoes removal surgery. First, the CT takes many pictures of the patient's body from various angles using the X-ray and shows the cross-sectional image on the monitor. Then, based on these images, doctors can assess the exact location and size of the tumor to decide on the operation procedures. Likewise, because CT allows us to examine a subject safely without damage, it is also used in various industries to examine the insides of subjects or to find empty spaces. When you compare an MRI, a diagnostic image device, with a CT, it has an advantage. Because it doesn't have virtual image of bones, MRI can take clearer images of the brain tumor or detect potential illness in the hollow of the occipital, which is hard to do with a CT. Besides, ischemic cerebrovascular lesions, caused by a blockage in the brain, or stroke, is often undetected by a CT scan in its early stages, whereas a MRI might be able to detect it. MRIs can even detect small lesions under 5 mm like light cerebral infarctions or the plaques that develop from MS, multiple sclerosis, a chronic nerve disease that occurs on the central nervous system, like the brain, spinal cord, and optic nerves. For these reasons, the MRI is used more often than a CT when diagnosing brain tumors and cerebral infarction. A hologram is a technology that turned people's imagination into the reality. It is a three-dimensional image technology. You could call it the dream and vision of the 21st century science technology. A hologram also appears in the blockbuster movie Star Wars. Although you can't physically touch a hologram because it does exist physically, an avatar looks, acts, and speaks just like people. Usually, when we use a camera to record videos, and there are only few options to watch it. For example, we could watch it in the movie theater through the screen or watch it through a TV. When you think of it, a hologram avatar is a subject that exists in a three-dimensional space, but we can only experience it from a two-dimensional screen. It's as if the things from 2D screen came out into 3D space. Therefore, we can say the hologram technology is realized on a three-dimensional space, not a two-dimensional screen. In other words, virtual videos appears in front of you and the person you talk to, where you can have personal and intellectual conversations with each other. We call the combination of the reality and the virtual world a mixed reality. It is a world the hologram technology has made possible. Because it is required to be filmed and seen 3D, hologram technology was considered only as a piece of imagination or a scene from a movie. However, with the advancement of IT technology, the potential of commercializing this skill has unlocked. As we mentioned earlier, there are three ways to project solid figures on a plane, using a geometry net, cross-section, or shadow. A net is a drawing that shows all the faces making up a solid figure on a flat plane. Geometry nets are often used when making the body of airplanes or cars because they show everything in detail. You can build any solid figure by folding a thin board. In other words, you can make a 2D object 3D. A net is also used when figuring out the shortest distance from point A to point B because it is not easy to find the shortest distance by tracing the surface of a solid figure. But if you draw the geometry net of a solid figure, the problem turns into finding the shortest distance upon a plane, so it is easier to find the shortest distance. The Fourth Industrial Revolution refers to an industrial age where the fusion of the digital and natural world impacts every area of the economy and society. The first industrial revolution achieved mechanization, the second mass production, and the third informatization. The fourth industrial revolution, through innovative technology like Internet of Things, robotics, virtual reality, and artificial intelligence is changing our lifestyle. Like the computer and internet acted as the pioneers of the third industrial revolution, the 3D printer is leading this new era, the fourth industrial revolution. Then what is a 3D printer? 3D is an abbreviation for three-dimensional. Thus, 3D printers are a piece of equipment that prints out three-dimensional objects, unlike 2D printers which prints on paper. The 3D printer was developed about 30 years ago but had only recently started to be used commercially. The usage of 3D printers has changed gradually over time, too. From just making prototypes and molds, today 3D printers are used as equipment for industrial production. With just a blueprint you can make a one-of-a-kind customized product. Also, with getting rid of the delivery process, you can obtain the objects you need in time, so there is no waste of space and expenses. Advanced countries, such as the US, are actively promoting 3D printing as part of their industrial advancement. For example, during the 2014 Consumer Electronics Show in Las Vegas, US, the biggest international electronics-related fair at the time, 3D printers featured as the key product. The National Aeronautics and Space Administration, NASA, was interested in the great potential this technology had to pioneer space exploration. They expected there to be great leaps forward in the space industry if we were to be able to make various objects with a 3D printer. They saw potential in making parts of spaceships, houses, and food on planets. For example, it costs $10,000 to launch 1 liter of water to space from Earth. It's also very expensive to repair one part of a component. However, if a 3D printer can be used in zero gravity, you can create replacement parts on the spot just by sending the designs to space. In other words, the dream of space exploration taken a huge step forward. The 3D printing technology will be the foundation of technical development for space exploration. Today 3D printers' scope of application is continuously increasing to various fields. They are also expected to give the biggest help to humanity through the medical field. The 3D printer is perfect for producing customized products for patients when creating various prostheses to be transplanted into patients. The range of application of 3D printing is broadening day by day, including orthodontics. For example, it is used in surgery for prosthetic treatment to protect undamaged teeth, orthognathic surgery, and even implant procedures. The most important reason for using 3D printing is to treat patients as accurately as possible. Precision is key in dental treatment. With commercialized 3D printers, doctors can make products with an error less than 10 micrometers. With the addition of 3D printers and key technologies from the fourth industrial revolution, the medical field has made remarkable progress. 3D printers continue to evolve, giving hopes for life to those suffering from diseases. However, the extensive use of 3D printing technology can pose risks on intellectual property rights or criminal activities. In the wrong hands, the 3D printer may be the Pandora box humanity should never have opened. An American organization uploaded on the internet how to make pistols using 3D printing technology. In less than 10 days, the number of downloads was over 100,000, becoming a big controversy. It was a shocking case that occurred because there were no guidelines on the new technology. The harmfulness of the material used also became a controversy. A study by an engineering college in the U.S. warned that the fine materials used for 3D printers can have a huge impact on a person's health. It is a serious problem that the material used is not safe. Hundreds of millions of fine dust are generated when printing with a 3D printer. People are at risk when they inhale those materials. There is also the danger of the metal powder used in metal 3D printers exploding due to high temperature. Solid figures also play an important part in art and architecture. The base angle of the two isosceles triangles from dividing the pyramid with a plane from the vertex to the center of the base is 51 degrees. Through the observation of nature, ancient Egyptians discovered that 51 degrees is the most stable angle and used it when constructing the pyramids. The ancient Mesopotamians built enormous landmarks with bricks. These buildings built by the ancient Mesopotamians are square or circular plains. Such building structure is known as ziggurat in the form of terraced steps of successively receding levels with flat space at the top. This structure was made even before the Ur kingdom and remained intact because it was so huge that no one could destroy it. Future generations of kings added new layers to the ziggurat, making even taller and bigger ziggurats. Kepler believed that the orbit of the planets can be explained in terms of layers of polygons. He proposed that the distance relationship between 5 planets from the Sun at the center can be calculated consecutively in terms of the 5 regular polyhedrons. He claimed that a cube can fit into the space between Saturn and Jupiter, a regular tetrahedron between Jupiter and Mars, a regular dodecahedron between Mars and Earth, a regular icosahedron between Earth and Venus, and a regular octahedron between Venus and Mercury. Studying math starts with observation. Through observation, you find unique designs and patterns, which is a group of designs. Understanding patterns help to find regularities in nature. However, within every living organism, creation and destruction occur simultaneously, and new dimensions of time and space continue to expand. More in-depth knowledge is required to understand the patterns and their destruction. The best way to cultivate such deep insight is to gain knowledge in humanities through extensive reading. The secrets of nature can also be the secrets of nature's creation, life, and extinction, death.